Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Math No Calculator section, question number 3. Alright, it starts. A landscaping company estimates the price of a job in dollars using the expression 60 plus 12NH, where N is the number of landscapers who will be working, and H is the total number of hours the job will take using N landscapers. So here you can see I've annotated, right? Kind of like the reading section. N is circled. What's N? N's the number of landscapers. What's H? H is the total number of hours the job is going to take. So we're tracking number of landscapers, how many landscapers did we hire, and then how long did the job take? How many hours did they all work for? All right. Which of the following is the best interpretation of the number 12 in the expression? There is, what does this mean? Now, this is an interpreting linear functions question. These kind of questions give you an algebraic expression, kind of explain what's going on in terms like a word problem in English. They're like, hey, here's this equation that we use to do this thing. And then they point to one of the parts of the equation. You know, hey, what's this 60? What's the 60 doing here? What's the 12? What's the N? What's the H? What's this? And they all have a similar structure. Basically, they're all asking you to translate an element of the algebraic expression into English, and they all follow the sort of same form. This question is no different. Well, it's a little bit different because it's a tiny little twist, but it's a smaller twist than you would think. So here, way up at the top, we're setting up we're going to set up the core structure that all linear functions follow, and that's this sort of y equals mx plus b structure that you're familiar with from graphing. And the sort of the English language, like what each part of the equations mean, is that the y is like the end point. It's the end result. It's the thing that we care about. Here, the y is the price, right? This is an equation to try to tell us what the price is. So here's the end point. And the m is going to be the rate. It's the slope of the graph. It's the rate at which stuff happens when things change. If you're saving up money, it's how much money you're saving per day or per week or whatever. Speaking of per day and per week, here the x in the y equals mx plus b is the thing that changes. If you're saving up money, it's like every day that goes by, how much are you saving? How many days have gone by? How many weeks have gone by? Etc. So this is the number of cycles. The rate is how fast things change per cycle. This is how many cycles have gone by. And then the b, the y-intercept, the thing that's all by itself in the equation, that's the starting point. Where did we start off? It's the initial consultation fee in the word problem. It's how much money you started off with in the bank in the word problem, etc. So here, if we're looking at this equation, here is 60 plus 12NH. They don't give us the entire equation, but they tell us in English that this landscaping company estimates the price of a job by using this expression, which is they take this expression, and that's how they figure out what the price is. In other words, the price is this expression. So we're going to take this equation, price equals this stuff, and we're going to shove it into this core structure because it's a linear function. It needs to be because this is an interpreting linear functions question. So price is off on its own. It's the y type thing. It's the thing that we care about. And then the 60 part, I think, is the second easiest thing. It's the number that's off on its own. It looks like the b thing. Another way of thinking about it is, this needs to be the y-intercept if you're graphing it, which is to say, if you set all the other stuff to 0, the price needs to end up being this. Which is, let's just say n and h, whatever they are, they're both 0. Well, this is 0 times 12. Well, that's still 0 plus 60. The price is going to be 60. Which is all just to say the y-intercept would be 60. The starting point is 60. 60 is sort of the base fee. Okay, so far it's following the structure. We've got the price and we've got the starting point. And so now we've got like 12 times stuff, and this is kind of where it gets hard. 12 looks like the slopey type thing. In a normal y equals mx plus b equation, y equals 2x plus 6, right? That's an equation that would be totally normal, and 2 would be the slope there. 2 would be the m. It would be the rate of stuff happening. So 12 kind of looks like that. And the only thing that's hard about this question is that instead of just having x, some one thing, we have nh, these two things. And this is a part where, like, if you're, you just started this section, it's the first math section, it's question number 3, and you're like, oh my god, they're asking me this crazy stuff. I don't know how to do linear functions with, like, multilinear dimensions. It's, like, way too many dimensions. I can't keep track of all this stuff. And this is where I want you to calm the hell down and remind yourself, this is question number 3. It is not a question that is harder than anything you've ever seen before, testing concepts that are from college linear algebra, multivariable calculus stuff. That's just not what question number 3 on the SAT ever does. What they often do, though, is trick you into thinking that you need to do some crazy stuff, when instead you really just are answering a straightforward interpreting linear functions question. That is the type of hardness the SAT specializes in. This sort of like masquerading, oh, I look scary, but really I'm not that scary type hardness. And that's exactly what's going on here. The mindset that I want you to have, if you're going to come to the solution that I'm about to describe yourself under timed pressure on the actual test, is to insist that this question is as easy as all the other questions that you've ever done. Which is to say, the only hard part of this question is that NH seems like it's two things. You know, like there's the number of landscapers and the number of hours when you track all this stuff. And you're used to answering these questions when, you know, there's only one thing. You're used to answering these questions when it's an x here instead of an nh here. But I want you to try to just insist that this nh is not two things, it's one thing. Can we treat it as one thing? If we can treat it as one thing, if we can treat it instead of as n and h, we can treat it as a nh, you know, then we know how to solve this problem, right? This is 12 times every nh plus 60 is the price. And this is, okay, so then 12 is just going to be the rate, the slope. So I'm going to explain what a nh is, and this is down here. What is a nh? Right? If we're trying to treat it as one thing, let's try to think about what each nh is. And nh comes from an n and an h. It's what happens when you multiply n by h. Let's think about, in English, what n and h each are. Well, n is the number of landscapers, right? And h is the total amount of hours that, like, everybody all together, like, we all worked for this many hours, which is to say, you know, I hired 3 landscapers and they all stayed for 2 hours. That's like all 3 of them sort of concurrently all working together for 2 hours, right? So that's what n is, that's what h is. And we're going to see what happens when we multiply these two things together. And I'm just going to go through a couple of examples, and I would encourage you to do this too if you're trying to figure out what nh is. And here, let's just say, okay, so the examples here is n is 1. The number of landscapers we have is 1. And the number of hours that we have is 2. So the total number of hours the job takes is 2. nh here, n times h here, is 1 times 2, right? Because 1 times 2, and that's 2. So when n is 1 and h is 2, nh is 2. This is a situation where one landscaper works for 2 hours, and nh, the nh here, that's 2. Okay, we're going to go through the second example and then think about what nh must mean. For the second example, let's just bump both of these numbers up a little bit and see what happens here. N is 3, so this is 3 landscapers now. And this is the job itself is going to take 4 hours. So we have 3 landscapers over at our house. They're all working together for 4 hours doing some job, right? This is a situation where 3 landscapers are working for 4 hours. Well, nh is going to be 3 times 4, right? Number of landscapers times the number of hours that the job took. And the nh is going to be 12. What nh is then is, and this is up here, it's the total number of hours that all of the landscapers like sort of each worked. This is sort of the concept of man hours. But this is like, all right, you worked 3 hours, you worked 3 hours. Well, actually, let's look at this one. You worked 4 hours, you worked 4 hours, and you worked 4 hours, right? So all together, all of the landscaper hours all put together, the total number of hours that all of the landscapers all worked, that's 12. So that's what a nh is, right? That's the concept that the 12 in the equation is being attached to. Here in this equation, we can think of it not as, well, yeah, and let's look up here, right? Instead of this being 12 times n times h, you can think of it as 12 is the rate that operates every time a nh happens. Every time a nh happens, there's a 12 that gets added, right? How many times are we going to add 12 to this equation? Well, how many nhs happen? 12 is the amount of, well, it's going to be dollars. 12 is the amount of dollars that we need to pay every nh. And here, nh is like every single hour that every single landscaper worked, right? It's not like, oh, you 3 worked 4 hours. Well, I'm going to pay you $12. It's like, oh, I need to pay each and every one of you $12 per hour each and every single one of you worked. And that's down here. Here, 12 is the rate, and this should be familiar here. 12 is the slope type thing. It's the rate that we pay in dollars, because again, here the price is dollars. It's the rate that we pay for every single landscaper for every single hour, right? Every every landscaper hour that happens, we need to pay 12 bucks, right? So that's how you get to A. We're going to try to think about NH as being one thing. We're going to force this to be an easy problem, right? Instead of some crazy multivariable calculus, oh my god, I've never heard of this before type problem. And we're going to think about NH as being one thing. We ask ourselves, what is that one thing? Well, that one thing, what an NH is one landscaper working 1 hour. Every single time a landscaper works an hour, we need to pay 12 bucks, right? So maybe that's one landscaper working 100 hours, right? Well, NH would be 1 times 100. That's 100. We need to pay 12 bucks 100 times because this one landscaper worked for 100 hours. Maybe it's 2 landscapers working 50 hours, right? Well, that's going to be the same thing, right? If 2 landscapers each work 50 hours, there's going to be like 100 hours total worked between them, right? Because one of them was working 50, the other one was working 50. We need to pay 12 bucks 100 times, right? 50 times to the one for working 50 hours, 50 times to the other one for working 50 hours. That's the way this equation works. All right, on to the wrongnesses of B and C and D. Here, let's just go one by one. Here, answer choice B, a minimum. And this is saying the best interpretation of the number 12 in the expression is that a minimum of 12 landscapers will work on each job. Here, we're going to try to translate this. This is an English language expression. Let's translate this back into algebra. What is it saying in algebra? In algebra, it's saying that the number of landscapers, that's n, right? N is the number of landscapers. It's saying the number of landscapers needs to be more than 12. It's saying that the role of the 12 in this expression here, this 12 right here, is that it sort of introduces this rule that n needs to always be more than 12. N is greater than or equal to 12. Well, there's no such rule in this equation, right? There's a completely permissible possibility where n equals 3, and this is what I've written here. Maybe n is 3, right? We have 3 landscapers. They work some number of hours, right? We pay them 12 bucks an hour. That's completely fine. There's no rule in there that n needs to be, it can't be lower than 12, it needs to be higher than 12. All right. There's the wrongness of B. On to answer choice C. The price of every job increases by $12 every hour. Now here, this would be right if instead of thinking about nhs, we were thinking about hs. If we didn't have the n in there and we only had hours in there, this would be right. Which is to say, this answer choice is only true when the number of landscapers is 1. That's this note right here. It's only true when n equals 1. When n is 1 and we have 1 landscaper, we need to pay that landscaper 12 bucks every hour. So every hour that goes by, we need to pay him 12 more bucks, more bucks, more bucks, more bucks, more bucks, right? $12 every single hour. That situation changes, though, when we have 2 landscapers, right? We need to pay each of the landscapers 12 bucks for every hour that goes by. So it's not true that every job increases by 12 bucks an hour. Because if you have more than 1 landscaper, if you have 2 or 3 or 4 landscapers, every hour that goes by, you need to pay all of them 12 bucks each. So whenever n is, this is this note right here, whenever n is more than 1, the price goes up by way more than $12 each hour. It goes up by 24 or 36 or whatever, some multiple of 12 every hour. All right, there's the wrongness of C. On to answer choice D. Each landscaper works 12 hours a day. Now this is, God, it's so confusing trying to explain this. But, okay, the role that the 12 is playing is not that each landscaper works 12 hours a day, in part because the units, if the units of this 12 were in hours, then there would be like too many hours-y type things in the equation and not enough dollars-y type things in the equation. Which is to say, like, another way of putting it is, like, if this is in hours and h is also in hours, if it's like, oh, like, this many landscapers work this many hours times this many hours, that's too many hours. You're going to end up with your units as hours squared, and nowhere in there are you going to have dollars, which is ultimately what we want. The units of 12 need to be the kind of thing that, like, take away hours and give me hours and I'm going to tell you dollars. That's what a rate is, you know. Tell me how many hours you've worked, and I'll tell you how many dollars we need to pay. So part of the wrongness of D, or I guess like one way of thinking about the wrongness of D, is that it gives you the answer to like what the function of 12 plays in the wrong units. It's not that each landscaper works 12 hours a day, because 12 isn't, that 12 in the actual equation isn't a measure of hours. It's a measure of dollars per hour for every landscaper. So that's this note here. It's redundant with H. It's in terms of units. It's redundant with H. And it leaves us without dollars. The dollars don't come from anywhere in the equation if we put 12 in the units of only just hours. All right, that's it for this question. I'll see you all in the next one.